Heartworm has been and continues to be a struggle to detect, especially early on in the infection. And I think what a lot of veterinarians don't realize is when heartworm first gets into the dog or the cat, it's in the tissues. It's chilling. It's not in the vascular system. It's not in the blood that we normally take a sample of to look for it. So it's living this kind of covert lifestyle there in the tissues until it becomes mature enough for us to tap into the antigen that's put out by the adult worms. Or if we're talking about cats, the immune response to the heartworm, which still has a lag time associated with detecting the antibodies there. So the good thing for heartworm is it can fly under our radars very well, especially early on in the infection, because the targets we go to look for, that we know to look for, are things that don't really exist until that infection becomes more mature. VOCs, volatile organic compounds, there's something technologically we've known about for quite a while. Think from the human health side. If any of you have ever been tested by your primary care physician or another physician to look for ulcers, you've blown air into a bag, and then they take that bag and they decide if you do or don't have the bacteria associated with gastric ulcers. I've had to do that before too. That is detecting VOCs, or these changes, alterations, which are kind of byproducts from something going on in the host. We exhale these compounds. These compounds are also emanated not only from our breath, from our skin, from our hair, from all over the place. If we can narrow down specific ones in breath associated with specific pathogens along the same lines that they've done with Helicobacter and gastric ulcers, now we've got a really non-invasive way to look for something like heartworm, which currently requires a blood sample. If we can use this breath technology for basically anything in the practice we would be interested in answering, I think that potential is there. What could be a miraculous tool to this non-invasive, all I need is your breath sample and I can get this whole portfolio potentially of what's going on inside your body, because that is almost the easiest window to look at what's going on inside. Not only is this VOC technology dog specific or heartworm specific, this is something that we can test environmental for looking for things in a housing type setting, commercial poultry, cattle facilities, right? We can do that. We can potentially detect VOCs coming off of a food source for detectable fungal signature. Everything has a VOC portfolio or profile that comes with it. Knowing what it means is the hard part. And so this is a technology that could expand far beyond dogs to other hosts, far beyond parasites into other pathogens, other infectious things. The breath diagnostic world is only going to explode from here, and that's super exciting. Andrew was persistent, and we got together and had some really intense conversations about building on what the Auburn team had kind of started back in, God, I don't know if it's 2017 or 18, a small team of myself, Dr. Byron Blackburn, and Dr. Sarah Zodi, but Andrew picked it back up, first starting with Byron and then with me, and there's a few parasitologists on the team, plus experts in all those other respective facets that bring this whole breath portfolio detection thing together.